Students, welcome to another lesson from iCampSA. In this particular lesson, we are solving a past paper question from 2018, and this one is a KZN past paper question, and the area of focus is trigonometry and including trigonometric functions. Let's get into it. Okay, so for the first question, we have question 3. So back from 2018 going to the years previously, the papers that were written were like common papers across all the provinces. I just wanted to make the clarity of that. So the papers were the same from KZN, Gauteng, Eastern Cape, Limpopo, all the papers were the same. Okay, let's get into it. So in question 3, we are given a data. So the statement is as follows. In the diagram below, triangle QPR is a right-angled triangle with angle P in QPR being equal to 90 degrees. What do we know about the side that is facing the 90 angles degrees? This side is the hypotenuse, side. Okay, and then next, use a sketch to determine the ratio of tan theta, tan of 90 degrees minus r. Why did I say tan theta? To determine the ratio of tan 90 degrees minus r. First thing first, which angle is angle r? Is this angle here? Okay, and then we have angle 90 degrees there at P. What do that tells us? It tells us that angle 90 minus r that we have here is essentially angle Q. That is the angle of which is 90 minus r. 90 minus r, because this is the angle r here, and therefore angle Q is the angle of 90 minus r. So what is going to be the ratio of tan 90 minus r? Remember your SOHCAHTOA. Let's quickly remind ourselves of the ratios. For sine, we have the opposite over the hypotenuse. For cos, we have the adjacent over the hypotenuse, and for tan, we have the opposite over the adjacent. Okay, and then for 3.1.1, we're asked to use the sketch to determine the angle of tan r, and I've just mentioned for you that tan 90 minus r is essentially the angle Q there. So we have to look at the side that is opposite to that angle Q of which is the side of PR. Therefore, this means that tan of 90 minus r is equal to, what's the opposite side? The opposite side is PR, is equal to PR over the adjacent side. What side is next to the angle of 90 minus r? The adjacent side is this one, QP. So it's PR over adjacent side, which is QP. Okay, and then let's go to 3.1.2. 3.1.2. Okay, so in 3.1.2, we are asked to write down the trigonometric ratio. That is, the trigonometric ratio is equal to QR over QP. QR, the trigonometric ratio of QR. What is QR? QR is the hypotenuse side. And what is QP? QP, if we are looking at that angle of 90 minus r, is what? Is the adjacent side. Okay, so this one is the adjacent side. We're gonna just use this angle of 90 minus r, of which is angle Q. Okay, so QR is the hypotenuse side over QP, which is the adjacent side. So this tells us what? It tells us that we are dealing with the reciprocal. So the reciprocal of what? Of cos, because cos is adjacent over hypotenuse. So this is gonna be the angle of, what is the reciprocal of cos? Is sec 90 degrees minus r. Sec 90 degrees minus r is what will be equal to QR over QP. Okay, that will be this. But for your answer, you only just have to write sec 90 minus r. Sec 90 minus r. Okay, and then from there, let's go to 3.2. Okay, I've added a page there, I think. Let's take this one back. since we have a space, and 3.2. okay, let me see. Yeah, let's use this one here. Okay, so for 3.2 s has the following coordinates of -3 and -4. okay, -3 is the adjacent side, that is your x value, -3 is your x value, and -4 is your y value. Okay, so if we were to construct our triangle here, let's use a different color. If we were to construct our triangle like that, we're gonna have, what's the value of y is -4, -4 this side, and then we're gonna have -3 on this side. Okay, so from this triangle we can clearly see that the only side that is unknown is what is SO, or OS if you like. And if you look at this from the eyes of a right angle triangle, that side is your hypotenuse side, so it can be calculated. Anyway, is a point S is a point on the Cartesian plane such that OS makes an angle of theta with the positive x-axis. Okay, so for 3.2.1 we're asked to calculate the length of OS without using a calculator. So for 3.2.1 we have to calculate the length of OS. What is OS? OS is the hypotenuse side, so we have to use the Pythagoras theorem to calculate OS. So OS squared is equal to x squared plus y squared. Okay, plus y squared. So in other words, x is equal to, what is x? X is -3 squared plus y -4 squared, of which this would be equal to -3 squared is going to be what? It's going to be 9 plus -4 squared is 16. And let's drop OS squared. What is 9 plus 16 is going to be 25. Therefore OS squared is equal to 25. And then we introduce a square root on both sides. Of which would give us OS. What is the square root of 25? That would be 5 units. That will be 5 units, and that's the length of OS, 5 units. Let's come here. So here we're gonna have 5. Okay, and then next we have to calculate the value of sec theta plus sin squared theta. Okay, so for 3.2.2 we have to calculate the value of sec theta plus sin squared theta. What is sec theta? Let's start by changing that reciprocal into 1 over cos theta, plus sin squared theta. Okay, so first thing first, we have the cos trigonometric ratio there. So what is cos? According to trigonometric ratios, cos is adjacent over the hypotenuse side. So let's come to our angle there. The adjacent side is x. So in other words, cos is equal to x over r. So let's start by putting it in that terms. So it's gonna be 1 over x over r. So it's adjacent over the hypotenuse, and then what is sine? The ratio of sine is what? Is y over r, and this will be squared. So once we're here, we can substitute the values. We have y divided by what is the value of x? Value of x is -3, and the value of r is 5. So we're gonna have -3 over 5 plus, what's the value of y? Y is -4 over 5, -4 over 5 squared. This is equal to 1 divided by -3 over 5. This will be a -5 over 3 plus -4 squared will be 16 over 25. Okay, 16 over 25. Okay, then once we are here, let's add these fractions. First thing first, we have to examine the lowest common denominator for these two. The lowest common denominator. of which I think it should be 75. Yeah, I think it should be 75. Let's go with 75. How many times does 3 go into 75? It goes 25 times. It goes 25 times, so we're gonna have 25 multiplied by 5 plus 25 into 75. It goes 3 times, so we're gonna have 3 multiplied by 16. This is gonna be 75 over 75, the denominator. 25 multiplied by negative 5 is gonna be negative 125, plus 3 multiplied by 16 is gonna be 48. Therefore we're gonna have, what is negative 125 plus 48? This is gonna be negative 77 over 75, and that would be your final answer. That would be your final answer for 3.2.2. okay, and then from there we are asked in 3.3 to determine the value of the following without using calculator, and we're given cosec for the 5 degrees, sine 90 degrees multiplied by tan 60 degrees. So you can see by the angles that we are dealing with there that we are dealing with what? With special angles, okay. So let's come here for 3.3. Let's drop this and just focus on 3.3, which is what we are interested in. Okay, if you don't remember the special angles by heart, if you don't know them by heart, let me quickly remind you by drawing these two triangles. These are two special triangles. They are right angle triangles, and then the first one has angles of 45 degrees, so it is an isosceles triangle, 1 unit and 1 unit here. You calculate the dead side by using what? By using the Pythagoras theorem, and therefore you're gonna have root 2 here. And then the other triangle, triangle B, it's a equilateral triangle with equal what you call this thing, equal side and equal angles, and all the angles for this triangle to be an equilateral triangle should be 60 degrees, because in an equilateral triangle, or in any triangle, the angles within a triangle are always equal to 180 degrees. And then before we write 60 degrees on the dead side, let's bisect or draw a line that is perpendicular to the dead side, and it bisects the dead side of the triangle. So as it bisects the dead side, it also bisects the angle from that point that we are drawing there. So we're gonna have 30 degrees and 30 degrees on this side, so instead of having just 60 degrees, but it's still 60 degrees if you look at it combined. Okay, so I'm saying that line that is drawn from that point, let's actually call that point A, and draw the line to point B. That line bisects the dead side. The side that line is perpendicular to, it will bisect it, which means it will cut this into two equal parts, into two equal parts. And another thing, all the sides for this equilateral triangle are equal to what? Are equal to 2 units, but instead of putting 2, we're gonna have 1 unit and 1 unit, which adds up to 2. Okay, once we are here, we can calculate the side AB. And how do we calculate side AB? By using Pythagoras theorem. So AB squared is gonna be hypotenuse side, which is 2 squared minus 1 squared. Therefore AB will be equal to root 3, So we have 3 sides. We can just focus on one angle, and then we can solve for any trigonometric ratio with the angle 30, 60, or even 90 degrees and 0. So generally in Trigonometry you only focus in 30, 45 and 60 degrees, but you can also work with 90 degrees and 0 actually also special angles. So sine 90, for instance, is what? Is 1. Sorry, is not 1. Sine 90 is, yes, it is 1. And then cos 90, the one that I'm confusing it with, cos 90 is 0. Okay, and then sine 0 is 0, and cos 0 will be 1. Okay, yeah, I just want to make that clarification there. Okay, so but in the exam, I always usually say that this, if you have already memorized the special angles, you know the special angles 0, 80, 45, 60, and 90 degrees. You don't have to redraw the triangles again. But if you haven't memorized them, these triangles will help you memorize the special angles. So first thing first, we have cosec 45, cosec 45 degrees over sine 90 degrees multiplied by tan 60 degrees. And we know that cosec 45 is the reciprocal of what? Of sine. So we know that the trigonometric ratio, or the ratio of sine, is opposite over hypotenuse, and the ratio of cosec is hypotenuse over the opposite, you know, because this is reversed. So here we're going to have, what is cosec 45? The opposite side, sorry, the hypotenuse side over the opposite side. We come here, what is the hypotenuse side in this angle, in this triangle, sorry, triangle A? The hypotenuse side is root 2 over the opposite side of which is 1, the opposite side which is 1. Okay, and then from there let's go to sine 90. What is sine 90? Sine 90 is also 1, so we're going to have 1 multiplied by tan 60. Tan 60, we come here, what is tan? The ratio of tan is opposite over the adjacent, so it's going to be root 3 over 1, so it's basically going to be root 3. So we're just going to have root 3 here, and we have root 2 divided by 1 of which is also root 2. So therefore here we're just going to have what? We're just going to have root 2 over root 3 as your final answer. Okay, so that's the way to go about answering that question. Okay, that is the way to go about answering that question. Actually the quickest way. But of course, if you do understand what you are doing, if you don't, you have to start by changing cosec 45 to 1 over sine 45 degrees over sine 90 degrees, sine 90 degrees multiplied by tan 60 degrees. Then from there, everything else you are familiar with. Okay, so that is that for 3.3. Let's go to question 4. Okay, let's do it like this. Copy. Yeah, then we can actually just drop this right up until there. Yeah. Okay, so for question 4.1, in the diagram, ABC, ACD, and ADE are right angled triangle. BAE is equal to 90 degrees, BAC is equal to 30 degrees, BAC. It is A 30 degrees, BC 20 units, AD 60 units. Okay, so first thing first, we are asked to calculate the length of AC. And what do we have? We'll start by focusing firstly on the triangle ABC. We have an angle of 30 degrees and an opposite side of 20 degrees. In that right angle triangle, AC is actually what? AC is actually the hypotenuse side. So we have an opposite side, a side that is opposite to the angle, and we're looking for the hypotenuse side, which trigonometric ratio we are supposed to use in order to solve for side AC. We are supposed to use the trigonometric ratio of sine because it's the one that has opposite and hypotenuse. So we're gonna say sine A, let's just say sine of 30 degrees, of which is A, is equal to the opposite side, which is 20 units, over the hypotenuse side, which is AC. Therefore AC cross multiplication will be equal to 20 divided by sine sine 30 degrees. Okay, so we're gonna have 20 divided by, what is sine 30? Sine 30 is a special angle. We come here, sine 30 is opposite over hypotenuse, so it's gonna be 1 over 2. It's gonna be 1 over 2. Sine 30 is 1 over 2. So 20 divided by a half is gonna be what? It's gonna be 40. It's gonna be 40. So this is equal to 40 units. And what we're looking for here is AC. So we now know that AC is 40 units. 40 units. Okay, and then let's go to the second triangle. The second one, which is A, C, and D. What do we have there? For A, C, and D, we have that side, which is 40 degrees, and the hypotenuse side, which is 60 degrees. And we are asked to calculate angle A, CAD, this angle there. Angle A, this angle CAD. Okay, 40. Okay, so CAD, we have that side 40, side AC, of which is adjacent. It is next to that angle A that we are looking for. And then we have side AD, which is 60 units, and the side AD is the hypotenuse side. So we are dealing with the hypotenuse side and the adjacent side. That tells us we're going to use which ratio? We're going to use the cosine ratio. So for 4.1.2 for size 8, so for angle AD CAD, we're going to use what? Cos CAD is equal to the adjacent side over the hypotenuse. Which side is adjacent? Is AC. It's gonna be AC over the hypotenuse side, which is AD, Okay, what is we're gonna have cos CAD. What is the length of AC? Length of AC is 40 divided by the length of AD, which is 60 units. Okay, and then for CAD, we have to take now cos to the other side. So we're gonna have cos inverse of 40 divided by 60. 40 divided by 60. Okay, and therefore this means that CAD will be now what? CAD, we have cos inverse of 40 divided by 60. That gives us 48.19. 48.19. It's 48.19. 48.19 units. And that is the value or the magnitude of the angle CAD. Okay, and then from there we'll also calculate side DE. Okay, now we have what? We have this angle here, which is 48.19 degrees, and then we have to calculate side, which side? DE. Side DE. We're now focusing on the third triangle. Okay, so we only have that one side there of AD, which is 60 units, but and we're looking for the side of DE. But I want you to pay careful attention here, because we have been told that all of these angle A combined are equal to what? Are equal to 90 degrees, and we already have the two angles which are left with this third angle here. And in order to find it, we have to say what? We have to say 90 minus 30 plus 48 degrees. That will give us the angle of what? DAE. Okay, that will be 4.1.3. 4.1.3. The angle DAE is equal to 90 degrees minus 30 plus 48.19 degrees. Okay, and therefore angle DAE will be equal to it will be equal to 11.81 degrees. And DAE is 11.81 degrees. Okay, now we have the angle DAE, which is 11.81, and then 11.81 degrees, and then we're looking forward for side DE, and we have that side it is 60 of 60 units, the adjacent side. We're looking for the opposite side. Which trigonometric ratio has the opposite and the adjacent side? And that is the tan trigonometric ratio. So for 4.1.3 we have to say tan of DAE is equal to the opposite side of which is what? DE, what we are looking for, DE divided by the adjacent side of which is what? Of which is AD, or just 60 units. 60 units. Therefore DE will be equal to 60 multiplied by tan DAE. Therefore DE is equal to 60 tan, what is DAE? Is 11.81. Therefore we're gonna have 12.55 units. 12.55 units, and that is the length of DE, 12.55 units. Okay, that is how you go about answering that question. Let's get to 4.2. We are now solving for x. 4.2. We have tan x is equal to 2.01. Okay, so we're solving for x. Solve for x correct to one decimal place where x is between 0 and 90 degrees. So x is an acute angle. X is an acute angle. So to solve for x on the first question, we have to take the tangent to the other side. So we're going to be left with x is equal to tan inverse of 2.01. Therefore x, we have to punch this in the calculator. You say shift tan to have tan inverse, or you use the second function on the other calculators. So the answer of x will be 63.5 degrees, and that is the value of x for the first equation as less than 90 degrees. So it's inconsistent with the statement. It is consistent with what we have been given. Secondly, we have 5 cos x plus 2 is equal to 4. Okay, start by taking the 2 to the other side. We're gonna be left with 5 cos x is equal to 4 minus 2 will be 2. Then you divide by 5 on both sides. Cos x is equal to 2 over 5, and you have to isolate x now by taking cos to the other side. X is equal to cos inverse 2 over 5. Therefore x is equal to shift cos inverse of 2 over 5. Cos is equal to 66.4 degrees. 66.4 degrees. That is your value of x. 4.2.2, and then for 4.2.3, 4.2.3 we are given cosec x over 2 is equal to 3. Cosec x over 2 is equal to 3. First thing first, cosec x is what? Is the reciprocal of sine x. But let's start by isolating cosec x by taking the 2 to the other side by doing the cross multiplication. So cosec x is equal to 2 multiplied by 3 is going to be 6, And then what is cosec x? The reciprocal of is the reciprocal of sine x. So we have 1 over sine x is equal to 6. Let's make sine x the subject. So we're gonna have sine x is equal to 1 over 6. You can achieve this by doing the cross multiplication, or by just understanding that if you take the denominator and make it the numerator on one side of the equal sign, you have to do the same thing on the other side of the equal sign. Okay, so what is going to be the value of x? X is equal to sine inverse. You take the sign to the other side of 1 over 6. Therefore x is equal to sine inverse of 1 over 6 is 9.6 degrees. Is 9.6 degrees, and that is how you'll go about answering 4.2.3. okay, and then next we have question 5. Okay, so for question 5, consider the function f at x is equal to negative 3 tan x. That negative 3 there, it tells us that the function of tan has been flipped about the x-axis, or it has been reflected, and it has also been stretched by a factor of 3. And also that 3, the absolute value of that 3, yes, it gives us the vertical stretch, which is the factor of 3. I almost said the amplitude, but the amplitude of the tan function is always infinite. It doesn't have an amplitude. If this was the sine function, I was going to say that coefficient of negative 3 gives us the amplitude, which will be absolute 3. But here we don't have those. Let's go ahead and do 5.1.1. So sketch on the grid provided in the answer book the graph of f for the range of 0 to 360 degrees. Clearly show all intercepts and asymptotes. Okay, so this is a tangent function, and in order to sketch the graph, let's quickly do a table. In order to sketch this graph. Okay, so just our table like that. Our table. Okay. And then we're gonna be using, let's use the intervals of 45 for this. So it's 45, 90, 0, 45, 90, 135, 170, 135, 180, and 225, then 270, 315. From 315 we go to 360, 270, 315, 260. Yeah, I think that should be enough. Okay, so the table is actually I should say, it's just a way to visualize or to organize what you are doing. But once you understand these functions, you can sketch this graph without actually doing the table. You understand that the tan function will have asymptotes, at 90 and 270 degrees, at 90 and 270 degrees. And then you understand that this function has been stretched by a factor of 3, and it is also been reflected. You can actually sketch this function, but let's not do that. Let's follow the protocol. The x values, we decided to go with 0 degrees, 45 degrees, 90 degrees, 135 degrees, 180 degrees, 225 degrees, and then 270 degrees, 315 degrees, and 360 degrees. Okay, and then for the y values, we're gonna use negative 3 tan x, negative 3 tan x to determine the y values. So we have negative 3 tan of 0, which gives us 0, negative 3 tan 45, which gives us negative 3 tan of 90. We get an error, as we have said that is where we have the asymptote. Negative t1 of 135 is 3, negative 3 tan of 180 gives us 0, negative 3 225 gives us negative 3 270. Again we have an error, and negative 350 tan 315 gives us a 3, and then 360 will give us a 0. Okay, so we have the points now. Let's sketch our function. Since we don't have the trig here, we will construct our own. Let me put the table a little bit lower so that it can be visible from here. Okay, and then for our trig, this will be our trig. Let's say 1.5 to 3. This will be our 3 here. 1.5, we use the intervals of 1.5, and then here is negative 1.5, negative 3, and then we have 0, 45, 90, 135, 180, 225, 270, 315, 360. Okay, 45 degrees, 90, 135, 180 degrees, 225 degrees, 270, 315, and 360 degrees. First thing first, let's just draw our asymptotes. We know that the first one will be there at 90, and then the second one will be at 270, okay. And then once we have those, we can sketch our function. At 0, where x is 0, also y is 0. At 45, we have negative 3. 90, we have an error. Tan 135, we have. At tan 135, we have 3. At 180, 0. At 225, we have negative 3, then an error. 315, we have a 3, and then at 360, we have a 0. Okay, we have a 0, and then from there we have to join our points. Each. I think it would have been actually okay. It kind of looks like a straight line, so instead let's change the value of 3 so that this function looks a bit better. Negative 3 here, and then we're gonna have negative 6. Yeah, let's use the intervals of 3 to 6. Then we change the point. This is where 3 will be located. 3, and 3. Yeah, just so we can be able to sketch it accordingly. Yeah, that's the first arm, and then here as the other arm. As the other arm. Okay, other arm there, and then lastly the other arm. So a few things about this function. You can see it has been reflected. Normally the sine function is start from 0 and goes upwards, but this one, it begins from 0 and goes downwards because it has been reflected about the x-axis. Okay, what do we have to show? Clearly show the intercepts and asymptotes. The asymptotes, first thing first, is x is equal to 90 degrees and x is equal to 270 degrees. That is our asymptotes. And then the intercepts, we have 180 degrees and 0. We have 360 degrees and 0, and then we have 0 degrees and 0. Those are all your intercepts, your x-intercepts. Okay, and then for 5.1.2, hence or otherwise, write down the period of f. The period of f. So how long it takes for this function to repeat itself. So the period of f for the tan function is 180 degrees, unless the function has been squeezed, at which point you will see that maybe they will introduce a coefficient of x there, x directly the angle. Maybe they'll give you tan 2x, but if nothing has been done there, so the function has not been horizontally shifted or stretched, the period will remain being 180. So for 5.1.2a, 5.1.2a, the period is equal to 180 degrees. Okay, and then for b, equation of h, if h is a reflection of f about the x-axis. So when we reflect a function about the x-axis, we simply introduce a negative sign. So for b, we are told that h at x is the reflection of f is equal to negative f at x is equal to negative f at x. That is how we reflect a function. But what is f at x? F at x is equal to negative 3 tan x is equal to negative 3 tan x. Therefore h at x, let's say h at x is equal to negative into negative 3 tan x, and therefore h at x will be negative multiplied by negative will be a positive 3 tan x, would be a positive 3 tan x. Okay, and then that was 5.1.2. that is how it go about entering that. Let's see. Okay, for 5.2 we have the function there sketched. Let's see, maybe we can even take it. No, it's not fitting. Let's put it on this page. Okay, so 5.2, sketch below is the graph of g at x is equal to a cos b theta. A cos b theta, that's the general equation for the cosine function, a cos b theta. Okay, so write down the values of a and b. A is the distance from the x-axis to the minimum or the maximum, but since this function start from the minimum value, we have to calculate distance from the x-axis, or from 0 to the minimum point, of which is negative 2. That will be our value of a. So for 5.2.1, a is equal to negative 2. And then for b, so this function it goes from 0 to 360 degrees. It has not been squeezed horizontally, so b will be just equal to 1. So nothing has been changed about this function. So b is equal to 1. B is equal to 1. You use the graph to determine the values of x. 5.2.2, by the way. Use the graph to determine the values of x for which g at x is greater than 0. So when they are saying g at x is greater than 0, we are essentially looking for those values of x whereby the function is above the x-axis, So, and we see that is from 90 degrees to 270 degrees. So we're gonna say the answer is where x is greater than 90 degrees but less than 270 degrees. That is where the function would be greater than 0. Determine the range of h if h is the image of g. If h is the image of g, okay, so h has been reflected, is just g being reflected and shifted down 2 units, is 2 units. So reflecting the function doesn't actually change the range of the function, but shifting down the function, shifting down is what will change the range of the function. So for 5.2.3, we have to determine 5.2.3. We have to determine the range of g first. What is the range of g? The minimum value for g is -2 and the maximum value is 2 itself. So the range of g, let's start by that. Range of g is what we are saying. Y is the element from -2 to 2. So -2 to 2. And then in order to calculate the range of h, we have been told that the range of h, or the function of h, is just the function of g shifted 2 units downwards. It has been shifted 2 units downwards. So we have to do this now. When we are shifting a function downwards, we subtract, right? So the range of h, we come to the range of g and we say y is the element -2 minus 2, shifting it 2 units downwards, and then the maximum is 2 also minus 2, and therefore the range will be y is the element, what is -2 minus 2 will be -4, and what is 2 minus 2 is 0, and that is the range for the h function. That is how you go about solving for that range. Okay, and then for 5.2.4, determine using the graph, okay, the value of 2 cos 0 to cos 1. Okay, so for 5.2.4, this one is actually just simple. It needs you to understand the angles, that when you add all the ratios of cos from angle 0 right up until angle 360 degrees, all those ratios will actually be equal to, it will end up being equal to 1. The negatives will cancel each other, and then it will just end up becoming 1. Or you can just prove that by actually calculating the ratio for 360 degrees, because that ratio of cos 360 degrees is actually the ratio of all the angles before 360 degrees added. So this is just an expanded version of that. You go from cos 0 right up until 360 degrees, but it's the same thing, just cos 360 degrees. So we can just say here we have -2 into cos 360 degrees. We evaluate that, this will be equal to -2. What is cos 360? That is 1. So therefore the answer will just be -2, will be -2. Okay, and that is how you go about answering. That is straightforward. It's just your understanding of how the angles work, and I think that marks the end of this lesson. It marks the end of this lesson. I hope you guys learned something from today's session, and I hope you guys fell in love with mathematics a little bit more after doing this lesson. And if you need more assistance, feel free to reach out to us at 067 or +2767 690 4778. This is the company number. You can text us on WhatsApp or send us a call, or call the admin. Anyway, I hope you guys did learn something from this video, and until we meet again, I wish you all good luck and good studying.